Before going to the next differential equation, we need to have a bonus lecture. In the next differential equation, we're going to do something very weird that we have to settle it right now. We're going to take the fourth root of a negative number. Look at it. Let's say alpha, we have alpha to the power 2, power 4 equals minus 4. So we're going to find alpha. This is quite bizarre and you cannot do it straightforward. If you take the root of this guy, you will end up with plus and minus I times 2, and then you cannot take the square root again. So we gotta do something fancy here. Okay, and meanwhile we will have a tiny recap on the complex numbers. Okay, so let's start with here. We know that we can write any number as complex numbers. I mean, in form of complex numbers at least. For instance, I can write the right hand side minus 4 to be equal to a plus bi. You see, I is that imaginary number, so we can say that I to the power 2 is equal to minus 1. Okay, so it's like I can write minus 4 in this form. So if I want to write it out, a would be minus 4 and b would simply become 0 because we don't have any I here. Okay, this is close to useless, but let us start with here and let's see if we can get someplace. Let me plot in a very generic form this a plus bi. Let me plot it on a complex plane. By the way, guys, this is called complex plane, where one of your axis is real numbers. So in here, in this complex number, this is the real number, and this is the imaginary number. So this we have a real axis and an imaginary axis. So I'll put the value of the real number on the real axis. Let's say this is a, and the value of the imaginary one on the imaginary axis, and let's say this is b. Okay, so these two coordinates would define a point which is a plus bi. Alright, that's pretty cool. Okay, but we can remember polar coordinates. We knew that whatever point we have, we can define it in polar coordinates. Let's do that here. Let's say that we have the radius between the center to this point. Let's say it is r. Okay, and I would say that this angle here is theta. Just naming them. We're going to figure out what they are. Okay. Now let me rewrite them. Let me find a and b in terms of r and theta. Okay, so a is equal to r times cosine theta. You see, I'm going to project r on this real axis, so it would be r times cosine theta will give me a. And you can clearly see that r times sine theta will give me b, and b equals r times sine theta. Okay, that is pretty amazing. Let's see. Given these, I can write this form of complex number a plus bi in another form. See, I can replace a with r cosine theta and b with r sine theta. I'm going to take r out. So r times cosine theta plus I'm going to write the I behind, times sine theta. Alright. Okay, so that's pretty nice. This form could be useful, but we need something else. There is this thing they call Euler's formula. Apparently, all of the formulas in mathematics is Euler's. formula which says that cosine theta plus I sine theta is equal to e to the power I theta. Okay, I'm not going to prove this, but just accept it, and you can find the proof online too. This is a very important formula. Okay, now let's accept that this thing is correct, and let us replace this thing on the left-hand side with I mean the thing in the bracket here with the right-hand side value here. So I'll say a plus bi equals r times e to the power I theta. Okay, this is a very useful form now. I can use it to rewrite this my number, my -4 that I previously wrote in this manner. I can write it differently. I can do this. I can write -4 equals r times e to the power I theta. Okay. Previously, when we wrote -4 equals a plus bi, we said that a is simply -4 and b is 0, so this is close to useless. But here, r and theta would have different numbers. Let's take a look at what they could be. So, for instance, let me write it right in front here. Okay, r could be just 4. Okay, I would say r is just 4. Okay, so e to the power I theta should be -1. Okay, how could it be -1? Let's take a look at this Euler's formula. So I want e to the power I theta to be -1. So what should be the value of theta here on the left hand side? I am pretty sure that if I want this side to be -1, there is no I term. So this guy should be 0, right? Sine theta, what's the theta that makes sine 0? Any number which is multiplied by pi would make sine theta is 0. So sine of 0 is 0, sine of pi, 2 pi, 3 pi, 4 pi, they're all 0. Okay, now there is another thing remaining. So I managed to make this guy 0. So cosine theta now should be equal to -1. Now, cosine of 0 is 1. Cosine of pi is -1. But 2 pi is 1 again, so it fluctuates between +1 and -1. So if you realize the odd numbers always have cosine -1. So you see 1 pi, 3 pi, 5 pi, they all have cosine theta equals -1. So I should put an odd number here. I will put 2k minus 1, given that k equals 1, 2, 3, 4, 5, anything it is. So if I put 1 in here, I will have pi. If I put 2 in here, I will have 3 pi. And all of this would make cosine theta equals -1. Okay, that was amazing. So let me rewrite my -4 in this form. -4 equals 4 times e to the power I 2k minus 1 times pi. Okay, that's what I have. So let me use this form and try to find alpha. That was our main question.